Hello, hello everybody. So this is going to be a pretty quick video for you on how to choose a sample size if given a margin of error when you're dealing with means. Okay, so in the past couple of videos I've talked about with means, for the most part, you're going to be using T distribution, T star, all of that fun stuff. Okay, it's only when you're dealing with sample size that you can use Z, because Z is going to be a little bit more accurate than T. And the reason we're allowed to do this, okay, is because in most of the problems that you'll come across, they'll be talking about like a previous study suggests this is the true value, like of the true standard deviation. Or in a previous study, they found this, right? So because we're technically using a population value or like a parameter, right, or an assumed true value for the standard deviation, that means you can use Z star instead of T star when calculating sample size if you're given a margin of error. Okay, so the process that we'll follow is very similar to what we did for Z intervals, but from the last unit for proportions, but because we're dealing with means, the standard error formula changes. Instead of P1 minus P over N and all of that under the square root, it's standard deviation divided by the square root of N, okay? Keep in mind that when you are actually writing a confidence interval, right, a confidence interval is your statistic plus or minus a margin of error, right? And the margin of error is your critical value times the standard error of the sampling distribution, which in this case would be like X bar, okay? So this turns into this formula here, okay? So your margin of error formula, switch over here. So your margin of error formula looks like this. So it's Z star times standard deviation that they give you in the problem divided by the square root of N has to be less than or equal to a given margin of error. Okay. This is kind of what you'll have on the actual AP test, right? Like on the formula sheets that you can kind of piecemeal together. But if you want to memorize the version of this inequality that has N already solved, essentially what I'm going to do is I'm going to multiply both sides by the square root of N to move it over here, and then divide both sides by the margin of error, and then square both sides to get rid of the square root to get N by itself. Okay, so doing that little bit of algebra gives you this, that N has to be greater than or equal to Z star times the standard deviation divided by the margin of error. Okay, and all of that has to be squared. I realize this does not look like a Z at all. Let's write that again. Okay, so let me clear my screen real quick, and let's look at an example. Okay, so in this problem, we're talking about trying to estimate the mean cholesterol level of a species of monkey. Okay, they say they want their estimate to be within 1 milligram per deciliter of the true value at a 95% confidence level. Okay, so this right here is my margin of error. Okay, 95 is obviously my confidence level. Okay, and they say a previous study suggests that the standard deviation is about 5 milligrams per deciliter. Okay, so that's going to be my standard deviation. Okay, so they want to know what's the minimum number of monkeys they'll need to get this margin of error. Okay, so part A here says find Z star and the standard deviation. So Z star for 95% confidence is always 1.96, which is one of those numbers that you probably will just end up having memorized at this point. Okay, my standard deviation is 5, okay, and my margin of error is 1. Okay, so this says next, plug in values and solve for n. Okay, so I'm going to start with this formula here and then kind of show you how algebraically it becomes this formula here with the n by itself. Okay, so I have 1.96 times 5 divided by the square root of n has to be less than or equal to 1. So what I'm going to do is multiply both sides by the square root of n and then divide both sides by 1. Right? So basically I'm taking this and switching them, okay, to get the n by itself. So I end up with 1.96 times 5 over 1 has to be less than or equal to the square root of n. And then I get 9.8 is less than or equal to the square root of n, right? That's multiplying 1.96 times 5. And then I'm going to square both sides. So what you end up with is n has to be greater than or equal to 96.04. And so I'm going to have to round up to 97 monkeys. All right. So if you go ahead and memorize this formula right here, you don't have to show all the math that I did right here, like all the algebra. I just wanted to show you, if you started with this first one, how you could do the algebra in order to get n by itself. But if you would rather just like memorize that formula right there, and then just plug the information in and not have to do the algebra, you can do that as well. All right, y'all. So I'm going to pause the video quickly. I would love for you to do the same. Try this second example right here, and then check back with me to see how you did. All right, folks, so go ahead and check your answer against mine. So here in this problem, we're estimating number of text messages sent by students at a particular high school during school hours. This person wants a 99% confidence level. Margin of error can be at most 2. Okay, and they're saying in a previous study, they got that the standard deviation was about 9, and we're trying to figure out how many students we need. So Z star for 99% confidence is 2.57, standard deviation is 9, and my margin of error is 2. So I went ahead and plugged those values into my solved for n formula here, just so I didn't have quite as much algebra to do. So you end up with n has to be greater than or equal to 133.75. So because we're talking about people, students, right, I can't round down, right? I have to round up to 134 students. So that would be the minimum number of students he would need to survey in order to have this given margin of error. All right, y'all, so that is it for this video, and that is it for confidence intervals for means. This is the last video in this section. So I will see you in the next video. Bye, y'all.